So today I want to do dictionaries. I want to talk about dictionaries. So dictionaries are unordered collections of items where each item is a pair of a key and a value. Dictionaries are an ordered collection of items where each item is a pair of a key and a value. Okay? Just like how old school dictionaries work. If you want to look for a definition of a word, you just open your dictionary, you go to the letter of that where the letter which that word start with. When you find the word maybe car, then you on that, so your car will be the key, then on that value of the car will be your definition. So this is how dictionaries work. So that's the same concept that was used in programming. So dictionaries, unlike lists, they use curly brackets. So dictionaries are created using curly braces or using this dict input function. The same as the list, we said list I can use square brackets or the list input function or constructor. So for dictionaries, we denote them by curly braces like this. So this is an example of how you declare dictionaries. Can you confirm if you are following with me so that I can know
Yes,
if I am?
we are following, but the voice is a bit low.
Okay. So for dictionaries, like I said, they use curly braces. Let me just open my tongue. Like this. I don't need this. Can you confirm if you are seeing my screen?
Yes.
Okay. So I want to have a dictionary, maybe for students and their marks, like this. So for dictionaries, we said you use curly braces like this. This denote that this is a dictionary. For list, if you remember, I said you use square brackets like this. Okay. Then dictionary it has a concept of what is called a key and a value. Key and value. So inside the dictionaries, you put your key, then you put a colon. Where are my columns? Then you put your value like this. This is the concept of dictionaries. Okay. So this is an example of. So if I run type for student marks, print type like this. Okay, so if I run this, I'll get that my data type is a dict, which stands for dictionary. So this was for student grades or student marks. Student grades or student marks, I can use that interchangeably. So this one says that John is an 85. Then the same as how we separate our items in a list, we use also a comma to separate our items inside the dictionary. Then I put, so these are keys, the John, the Emily, and the Anna. And these are values. 92, 78, these are values. So if I want to assign another item here, I'll just put a comma, then I'll put my key. Maybe this is Ben. Then I'll put value for value, which is the mark for Ben. Then I'll put a full colon. This says that what comes next is the value. So maybe Jen is 12. Okay. So this is how we define dictionaries. Then dictionaries are also mutable. Where is it? Okay, dictionaries are also mutable, same as a list, which means we can add and remove items from a dictionary. If you remember the word mutable, we say that it means that you can change. So you can change the content without changing the identity. So we do have our dictionary student grades here. So this is the contents that we are talking about, which I was saying it's mutable, which means I can change the value for John, I can change the value for Emily, and I can also add another member, which I did here, but I did this programmatically. So I did this by putting hard code, so you can do this programmatically. Okay, so this is the first thing that you need to know. Dictionaries, we use curly braces, or we can use the dict function. Then to access elements inside the dictionary, if you remember so well, for list, uh, if I had my student grades as a list like this, which is equals to, let me have the same list in this. So these are student grades, right? As a list. But the dictionary allows you to put a key and a value, but a list doesn't allow you to do that. So this is student grades as a list, but for list we say these are square brackets. So to access a list, if you remember, so let me just name this student grades 1. For us to access items inside the list, we said we use index. So if I want to access the first element, I'll put print here, then I'll put here, then I'll put in index. Then inside index, we use these square brackets. Then inside this, you use numerical values, like this is first item here. Then let me comment this so that it won't run. So if I run this, I should get the first mark, which is this one. But for dictionaries now, we also use index, but whatever you pass inside will now not be a numerical value, will be a key. So that's a difference on how we access. Let me just copy. Due to the sake of time, we want to make sure we finish dictionaries and tuples. So this is how you. So instead of the numerical value, which is an index here, you put the actual key. So if I run this, I'll get mark for Emily, but Emily here, so it will return 92. So let me just use the journey so that I'll get the same 85 that I had here. Okay, so if I run this, I'll get 85 here. So this is the mark for John. But if it was on list, if one mark for John, we know that John is a John's mark is the first element. So for list, so this allows to combine two lists. We have a list of marks, which is 85, 92, 78, and 21. We have a list of names, which are our keys, John, Emily, Anne, and Ben. But if we were using list, the same concept will be represented by student grades and student names here. So student underscore names, which will be equal to a list again of strings. So that's when we have John, Emily, Anna, and Ben. So this is called a one array list or one dimensional list. So this is now a representative of this using dictionaries. So instead of two lists, a list of names and a list of marks, we now have one dictionary which we can call student grades, which have the student names and their marks. So now we're saying in dictionary, we put the key here instead of the index. So what it happens here, when I run this code, it will loop through all the items in the dictionary and it will find for any key that is this value. For any key that you've passed here, I'll look for that key inside the dictionary here, then I'll return its value. But what happens if I don't find that that key that I'm looking for? So I'll get an error. Why? Because I've tried to loop through all the elements of the dictionary, but I couldn't find any key with this value here. So this is how dictionaries work. So we have defined the dictionary here. We have accessed So this is the accessing part. The concept is the same. We're using index, which is a curly brackets, but only that we are not passing the index value. We're passing the key of a dictionary. Then it will return you the value. Okay. Then moving on, how you modify is the same as how we modify list. If you are to modify whatever you want to modify here, it has to exist in that dictionary. The same as how we modified list. We said you say student, if you are student, have student grades, our list that I had like this. So if I have student grades like this, if I want to modify the first element, I'll say student grades index 0 is equals to the new value, right? But that 0 has to exist, which means my list has to have at least one element. So here, if I want to access the last element, I'll say, if I want to modify the last element, I'll say student grades. Let me just copy this. Student grades at index. I want to modify the last element, so I'll go to the length of my list. But what is my list name? Is this one. Then I subtract a 1. Then I'll say is equal to, and the new value. Maybe this person didn't have 21, but this student grade was created saying this student is 21, but actually this student is 22. So what will happen, it will go and modify this. But this one will not throw an error. Why? Because it will try to get the length of your list. So this index will always exist. Okay. But what happens here, if I try to put a value to, so let me just comment this. So if I run this, I will not get an error. Okay. But actually, I haven't printed the new list. I haven't printed the new list. So let me just do that. Okay, let me remove this print statement so that it will print the new list here. We did this yesterday. So as you can see, this is my new list here. But my new list has 22 instead of the original 21. Why? Because I've modified here. So this is now modifying, but this is modifying list. So, but it uses the same concept. Whatever you are passing here, it has to exist. So this is index, right? But the dictionaries doesn't use index to replace. It uses the keys. So you replace it. You put a new value to a key, but that key has to exist in the first place. So yesterday we said if I now to replace index 5, but I don't have index 5 here, so I'll get index out of bounds error, which is this one. So the same is that same replacement is the same one that is being used on dictionaries. So let me just go back to dictionaries. Okay. So let me just give this. Okay. Okay. Now we want to change the mark for Ben. So you just need to say okay, typing. So the key here, then that key has to exist. My Ben now has 22. And if true, but Ben originally had value for Ben. But what okay? Instead of modifying Ben now, unlike in list, instead of modifying Ben, that key Ben doesn't exist that I passed here. So instead of modifying Ben, it will now create a new key and a value pair, which you to assume that we want to put 22 as a value for Ben, but Ben doesn't exist originally in our dictionary. So it will create a new value for Ben. So in my print statement there, I will have this Ben and this Ben. So if you want to replace, if you want to modify a dictionary, that key has to exist. Same as in list, the same concept is in dictionary. That key has to exist. Only that in list, if that key doesn't exist, you get an error. But in dictionaries, if that key doesn't exist, it will assume that you want to create a new key. So take note, if you are to modify that key has to exist, you have to write it as it is. So if I write it like this, so now my bin has been modified. Then moving on to adding a new key and a value. So this is how you add a new key and a value. The same way you modify, the same way you add. Only that this time, if you add, and if that something doesn't, if that key doesn't exist, it will be added. If it exists, it will be modified. Take note, if that key exists, it will get modified. If that key doesn't exist, it will get added. Okay, so that's the same how you add a new key to a dictionary this way. So if I'm to add John, do I have John here? I have John. If I'm to add Mary, I'll just say Mary is equals to Mary as 40. So if I run this, I'll have my original dictionary with this one, but Mary has been added to my dictionary. But if I had Mary earlier in my original dictionary, Mary will now be modified. That's the only difference between lists and dictionaries. But the key difference is that dictionaries use a key and a value. List uses items of any data type. Then to remove, we use the delete keyword. Where is removing? Removing a key and a value. So in dictionaries, you cannot have a key without a value. A key will move along with the value. And a value cannot be there itself. It has to have a key. So these two, they move together. Okay. So if I'm to remove a certain item inside a dictionary, I will use its key to find the value. Then I will remove the key. Then that will automatically remove the value of that key. So we will use the delete keyword, this one, to remove any particular item inside our dictionary. So if I am to remove Emily here, so I can say delete Mary here. Delete Emily here. Then we will see that when I run the new list, my list will now be shorter here. Okay. Unlike in list we said you put your list name. If this is my list, only that this is curly brackets, so it is a dictionary. But if it had square brackets and if items inside there were only comma separated, not with full colons in between, I would say student grades dot remove. We did the remove function. Then inside here, you put your value that you want to remove. Okay. But for dictionaries, we use the del keyword. So this is an inbuilt this is an inbuilt reserved keyword that is used to delete an item in a dictionary. Okay. Then that's it on dictionaries. Any questions on dictionaries? Hello, any questions on dictionaries?
No questions.
Okay. Then last but not least, let's go on to tuples. Okay. We've covered this one. Okay. Moving on to tuples. So tuples are ordered collections of items similar to lists, but tuples are immutable, which means that once we create them, we can no longer modify them. So once created, their elements cannot be changed. So lists and dictionaries are mutable. Tuples and sets are not. Okay. How do we create a tuple? We use these round brackets. Okay, so we said for list we use square brackets. For dictionaries we use uh, curly braces. For tuples we use round brackets. These ones. Okay, so you should know this by your head. So let's do our first example. So here, this is the first example of coordinates. We've created a tuple called coordinates, which is value of 10, 13, and 30. These are my coordinates, right? So a tuple, when we say it's immutable, we mean that you can access it, yes, but you cannot modify it. You cannot. So we said here when we first introduced these data structures, we said we want to do creating, right? That's what we've done here. We've created. We said we want to do accessing. This one you can do, but modifying you cannot. Iterating, of course, you can iterate, but only that modifying. This modifying is now that it's being defined as tuples are immutable. Lists are mutable. It means you can modify or change the values of your items. Dictionaries are mutable, but tuples are not. Tuples are immutable. Okay. So I can print my first element inside my variable tuple called coordinates. The same way you access list is the same. You use square brackets, but only that the value pass depends. If it is a list, you put index. If it is a dictionary, you put a key. If it is a tuple, you put an index. So this one should print 20. Why? Because that's what is my index one. Index is the concept of index does change. The first element is always the index 0, index 1, index 2. So my list has 3 items. Then I might, now this is 2, not 3. Then my uppermost or my highest index is 2. But my list, my tuple is 3 items. The same way you get length, it doesn't change. You just put len, you put your variable inside, which is coordinates. Let me just copy this. Okay, like this. It doesn't change. These are not proper Python programs. Let me just remove this. How you get your length, it doesn't change. Okay. The same way how you access, you put index, like what I had earlier, index. But the only thing with indexes, right, is that that index has to exist. So here I'm trying to access index 1. It will be valid. Why? Because I do have that item in my list. And if I put index 2, I'll get my item, which will be 30. So if I put 2 here, so this will be 30. But what happens if I put 3 here? So I'll get an index error, this one. Why? Because I'm trying to access the fourth element in my tuple here, but my tuple is of length 3, right? So same with tuples. So now I also put this code that will try to modify my tuple here, and you see that it will tell me what I'm trying to do is not doable. Okay, so I've tried to change the value for 20 here to 25, the same way I had if this was a list, right? So let's change this to a list by just putting this. This is now a list, and if I run this, it will change 20 to 25. Let me just print the print coordinates. So this should be 20, 10, 25, 30, as you can see here. Why? Because this is a list, and we said lists are mutable. It means we can change the value of whatever is at index 1, which is 20, because this is at index 1, to our new value here. But if it is a tuple now, If we change these brackets to round, this is now a tuple. We said tuples are denoted by round brackets. If I run this, it will tell me that this tuple is does not support item assignment, which means once you define them, you can no longer change. I think also mentioned that once you define them, you cannot be changed. Okay, once created, you cannot change the values of your items. Okay, so this is tuple. Uh, so tuples are often used for returning multiple values from functions. For example, this example that I had, when you pass, I did see Elena who made use of tuples solution. I'm not sure which solution was it, no, but I saw Elena who made use of tuples, and I was like, wow, some are getting ahead. Okay, so here I'm trying to get the minimum and maximum value inside my. This is a list, okay. But where is the tuple here? The tuple is here. So we said minimum, it gives you the minimum, but what do you pass it? It's a list. Well, max is a function that gives you the maximum value and you give it a list. So this should give me, this is the minimum value. This should give me 1, and this should give me 8 here, since 8 is the maximum value. So the whole thing here will return a tuple with 1 and 8. I did put an output here. So if I run this, I'll get 1 and 8. I can also maybe say I want another value here. Maybe I can say numbers first index plus last index here. So I can say numbers. Let me put this in a bracket. Numbers first index, then add that with the numbers. Okay, what have I done now? Okay, with the numbers last index. But how do I get the value of the last index? We said you can say length. You can use the -1, or you can say length of numbers, then you subtract 1. Then I need to close this bracket that I had opened. So this should return 1 because of this, 8 because of this. And what will be returned here, if I may ask? What will be returned here? So on my tuple here, this time it will return 3 values. But what will be returned here? I want the value that will be returned after 8 here. What I have highlighted here, what will it return? If you're not seeing, let me just zoom out. Hello? I'm asking what will be returned here.
Any feedback? Linet, unataka kusema kitu? Gloria says 8. Yes. That's the maximum. The highest number. Valerie, your response? Ali, any idea? So the response is the others are still thinking. There is 8 and there is 9, and the rest are thinking.
9. Okay, what's my numbers at index 0? We talked about indexes, right? We said the first item in your list is the one that you say at index 0. What's the value for this?
5. They say 5. It should add.
Then we do have a plus here, right?
Yes.
Then what's my last item in my list? This is my list, right? That we have passed
Why is
here.
the last?
Because these numbers here is the variable that we've passed. We talked about arguments. This is the argument that I've passed. But
Mm-hmm.
when I run the get minimum and maximum, I pass the list. We said
Mm-hmm.
this one is a list. Why? Because it has square brackets. Then when I say numbers at a negative index, what will be returned here?
Response, you still retaining 8? Okay, so what is your feedback? Mhm.
What's
Tuna-
the value for this? What
tunasema-
am I allowed? What is
So
the value for
the
non
value for
negative?
that is 3.
Right. Why? Because I do have three, right?
Mm-hmm.
Then we do have this. We say this is an arithmetic operation. Why? Because this is a numerical value and a
Yeah.
numerical value. But here we
Mm.
said we have 5. Here we said we have 8. So this will return 5 plus 8. And I'm not sure 5 plus 8 will return 9. Okay.
They're
Then, but
saying
my
five.
return
They're saying it's 5 plus 3, not 5 plus 8.
5 plus 3, sorry. It's 5. Why? Because 5 numbers at
The
index 0
students
is
are.
5. And numbers negative 1 return minus, we return 3. Then we are adding 5 plus 3. Then the 2 resulted to 8. Then my return function here is returning a tuple because of these round brackets here. Okay. So when I run this, I'll get 1, 8, and 8. So if I run this, I'll get this result. Okay. If the tuples been understood, before we move on to sets, have the tuples been understood?
Anyone with a question, clarification?
On tuples,
Ali, uko sawa? Valerie, Lynette, sawa?
any questions on tuples?
Um, we okay.
Okay. Now let's move on to our last data structure. So these are all data structures: lists, dictionaries, tuples, sets. There are some other data structures that I didn't put there: arrays, multi-dimensional arrays, and so forth. But these are the most common ones: lists and dictionaries in tuples. Yeah, sets some use them, but not most. So these four under data structures. Then sets are unordered collections of unique items. Then sets are mutable and are commonly used for membership testing and eliminating duplicate entries. So if I do have a set, the items inside that set should not contain duplicates inside my set. So inside the list or inside the tuple, I can have duplicates. Like I can have my list as numbers. So numbers, I can say for numbers, I have 2, I have 6, I have 9, I have 2 again, I have 1, I have 1, I have 1. This will work fine. I will not get an error. Okay. I can print numbers. I can print numbers. Okay, this will print my numbers. But as you can see, I do have duplicates here. I have 1 and 1 and 1. I also have a duplicate here. I have 2 tools. Now, since they say no, this cannot be possible, which means it says they disallow duplicates inside your values. That's what is being said here. An ordered collection doesn't matter the order, right? It can be smallest to largest, largest to smallest, and it can be strings also. I can have names, alphanumeric. Just a second, I just want to take my charger. Uh, See, my laptop is running out of power. Okay, so saying now tuples, they say whatever values that you have in your list should be unique. Okay, by unique, which means we should not see some repetition of values. So we can have this example is our set, and also set make use of curly braces. Only that this time I will not have key and values, so it will be a set. But if I put full colons and uh why is it failing to copy? It wants me to write manually, right? Okay, so I can, this is my set. I can print this, right? And I'll get my set here, and I can print the type of, like I can put the type here. Yeah, you see that this is a set. But the moment I put, so sets and dictionaries, they use the same curly braces, but only that dictionaries will say before you put the second item, the first item has to have a key and a value. So if this was a dictionary, I would have a key here. Maybe let's put maybe alphabetical letters. You put uh, full colon to specify that this is now a value. Then I'll put a B here. Then I'll put my colons here. Okay, let me just repeat these keys so that I won't waste much time. Okay, okay, like this. And now put full colors. Okay, and put here. So if I check the tab now, so I do have the same values, yes, but now I do have keys. So this will now change. Instead of a set, this will now be a dictionary. So that's the only difference between sets and dictionaries, in that dictionaries can have duplicates, duplicate keys and duplicate values, but sets they don't allow you that. Okay, I just wanted you to note that difference. So let's proceed. Okay, so if I check the tab now, this will now convert to set. Okay, so sets are mutable. Where is it written? Sets are mutable. Okay, yeah, sets are mutable. So when a data structure is mutable, it means that you can modify it, right? We can modify it. So the same way you modify, only that for sets we use this inbuilt function called add. So for us to add a new value here, I just need to, okay, let me just print them first before I print the type. So I do have from 1 to 5. Then again add, let's copy this, dot add 6 here. And if I run here, but take note, whatever you add, it will be appended to the last item. Okay, but in list you can specify I want to add this to this index. If you remember, we said for list you can say, if this was a list, though it's not a list, but if this was a list, I can say this at this index, maybe 1, then I put the new value here, like this. But how you add to set whatever new value that we've added to your set, it will append it to the last. By default, it will be appended to the last. So you can see that list sets are mutable since I've added 6 to my original. Then you can also remove using the remove function. If you remember so well, which other data structure we used this remove function? Which other data structure we used the remove function?
I say list.
Which is true. So the remove function works the same as how you use it on the list. This value will now be treated as an argument, which will be searched inside the values of your set. So this argument that you are passing here, it has to exist inside your set. If it doesn't exist, you get a key error. So you get an item not found. So let me just try to remove 7 here. Dot remove. What do I want to remove here? I want to remove 7. But do I have 7 in my set? No. So I'll get a key error. But I can remove 3. That will run fine. As you see, I have 1, 2, 4. I now no longer have these 3 here. So which shows that sets are mutable. So the only data structure from the ones that we have learned, the one that is not mutable is the tuple. Okay? So we did list. These are mutable. These are mutable. And they are denoted by what? By square brackets. We did our dictionaries. Dictionaries. These are also mutable. And they are denoted by curly braces. We did our tuples. These are immutable. We say anything that is not mutable is immutable. And tuples are denoted by round brackets. Then lastly, sets which are mutable and sets are denoted by curly braces again. These are denoted by curly braces. Okay, so these are the data structures that we have covered. Any questions there? So with what we have done, we should be good to go on your assignments. Maybe we'll do this example. This one example that I put here, then you'll be good to go on your assignments. But any questions on what we have covered here? Any questions? Particularly, I mean that any questions on sets, because from this session, I didn't get any questions. Any questions on sets?
None.
None. Okay. Okay. Since we have covered dictionaries, we want to do the for loop. We covered control structures, right? When we did the while and the for. But for the while, we were using a Boolean condition, which is while something is true, then you execute the body of code. Then for the for, we used the range, right? If you remember for the for, um, we said for I in range, then you put a range here. Maybe I can say 5. and I'll print an I. This is what we did for the 4, right? Which we said it will print from 0 to 4. Now we want to do what is called for an in. An in, it allows you to, for I in a certain data structure. So this is now a data structure, which can be a list, a dictionary, a tuple, or a set. So what this will do now, it will iterate through the elements of your 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 data structure. So earlier I had let me just roll back where I had a list or a tuple, a dictionary. Okay, I had this. So I can say for I in. So instead of putting a range here like this, I may want only to iterate through the elements of my dictionary here. So I will now say not a range. I'll put my dictionary name, which is unique. UNIQE numbers like this. Then I'll print I here. So this should print these values. So if I run this, as you can see, I've got 1, 2, 3, 4, 5. Okay. Same if this was a list, maybe a list of names. John. Okay. How do I close my? Oh, I'm failing to find my other closing brackets. My keyboard is more of a Russian. So, okay, is this one. Then end it like this. So if I want to iterate through this item, not using a range, so these are no longer unique. These are now names. So I can say, so this has to match with your data structure, but this one can be any variable. So instead of an I can say for name in names. Like this. So I'll print a name here. So I'll get my names here. The same as, like I said, that this one is a variable. It's a variable. You can put anything. I can use I can use the A, I can use B, I'll get the same results. So this is how the for loop works to iterate through data structures. So this is now iterating through data structures. Same as this example, I had this data structure, which is a dictionary. As you can see, this is a dictionary. Let me just copy this. Okay. So this is the dictionary, right? We have John, and the John's grade is 85. We have Emil, and it's 92. Then we have our 4. Okay. This time, it's not only putting one variable here. It's now putting 2 variables here. But why? Because this is a dictionary. So a dictionary has two a key and a value for each and every item. So this is now saying student and grade in student grade dot items. So this is now how you access a dictionary to loop through a dictionary. So you put the items at the end. But if this was a list, I will only say student grades here. Then since list make use of only one value per item, I will not need 2 values here. I only need 1 variable. That's how I access my list. And for this one, I'll put 2 values, 2 variables here. So this one will represent my keys here, and this one represent my values here, 85, 92, and 78. Then now I will say my dictionary dot items. So these items has to be items. This one can be any name. It will depend with how you have named the variable. But this one has to be items because dictionaries you iterate through them using the item keyword. So it has to be items like this. Then I can print student and the grade. So this will print John and his value, Emily and their value, Anna and their value. So if I run this, I'll get this output. Okay. That's how you iterate through them. For tuple is the same as our SSL list. Since this is the one value, one value, one value, you only need one variable here, and you put your array name here, then you print your variable, or you compute any logical computation that you may need to do. You can compute using the variable that you have named here. Okay. Any questions here? So the only one that is the only one that is the minor difference from others is the dictionary. But the rest are the same. The rest, how you access them, are the same. Okay. So by that, that concludes the end of this session, and also the end of our data structures. I hope you'll be able to answer assignments without any issues. Okay. Any questions? So we've covered modification, iterating, creating, and accessing, and we did these data structures. So okay, this ends, or this marks the end of my lesson.